Okay, here we are for our Lab 4 video, Chapters 13, ANOVA, and Chapter 15, Correlation. So, we are looking at our homework assignment, which is posted on Blackboard. So this is the Lab 4 instructions. And we're reminded that there's always going to be bookwork, a PSPP output, which you can save as a PDF or you can print out, and questions about that output, right? So we call those lab questions. So you'll put all three together and turn them in on the due date. So we have problems for chapter 13, right? So here are the page numbers and these are the problem numbers. And they're all odd, so you can check your own work, right? Of course. Chapter 15, you only have 3 problems to do. And you have 2 parts for the PSPP assignment. So you are going to use Lab 4, and you are going to do your own ANOVA, and you're going to answer these 4 questions here about that ANOVA. And then for part B, you are going to do correlation with these 2 variables for the college data set, and you're going to answer questions about the correlations. And you're going to turn in all of this bookwork and PSPP, so you'll have 2 separate PSPP outputs, and you'll have your answers to the lab questions above. So let's look at the PSPP guide for using PSPP to do these things, and I've got some examples for you, so I'll do a little demonstration with the employee data set. But at the top, we're reminded that we are doing ANOVA, and we have to report our ANOVAs using APA style. So you'll always say F, degrees of freedom between, degrees of freedom within, equals our obtained F ratio value, and then our p-value. And of course we have to interpret that p-value, so if it's less than 0.05, then we'll say, woohoo, significant, and we will report the exact p-value that PSPP gives us, unless it's less than 0.01, then we don't, if it just says 000, we don't know, it could be a smaller number, it could be truly 0, so we say p less than 0.01. Now, if it's greater than that, we report the exact p-value, the exact significance level. So let's look at our research question. Our research question is, using our employee data, we want to know, are there any differences in the amount of previous work experience based on the type of job a person has in this company? There are 3 types of job in the company, right? Clerical, custodial, and managerial. And we have an independent variable with more than 2 levels, so we know we would use one-way ANOVA because we have 1 independent variable, 1 grouping variable, so the job type, and 1 dependent variable, which would be the previous months of experience. So we are going to go into our data set and we're going to conduct our one-way ANOVA. So I'm actually going to move this so I can show you both at the same time. So I like to have my instructions and my data open at the same time. So I'm on a Mac, so I have to open PSPP first, then go to File, Open, and I have to find my file. So I'm going to find my employee data. I'm going to click Open, and this is my output, so I'm going to minimize that. So here's my PSPP window. And I'm going to say, okay, what do I do to do my one-way ANOVA? I'm going to go to Analyze, Compare Means. Look at that. There's an option for a one-way ANOVA. Woo! So I click on this and my dialog box opens. So I remember, okay, my dependent variable, what I'm measuring the differences in, was previous experience in months. So I'm going to find, there it is, previous experience in months, and I'm going to move that into my dependent variable box. And now my factor, my independent variable, how I'm grouping them, was job category. So that was employment category. So we're going to move this to the factor box down here. And I'm going to click this little box here for descriptives because I want to know about the means and the standard deviations and the sample sizes and all this. All I have to do now is click OK. And then I have to go find my output. So PSPP, where did you put my output? Uh-oh. There we are, output. Here we go. So now I have my output and I have my descriptive. So I have my 3 types of jobs, right? Clerical, custodial, and managerial. I have 363 clerical, 27 custodial, and 84 for the manager position, with a total of 474 employees in my fake data set. The mean, remember, is your average month's experience. So on average, right, the clerical workers have 85 months of experience, custodial have 298 months of experience, and managerial have a little more than 77. But then look at their standard deviations. Now remember, these are in months. So you have a really high standard deviation for all of the groups, but you can see that there's one group, right? 298 is much different than 85 and 77. So I suspect we're going to find significant differences, but we get to check this. Our ANOVA will tell us if they actually are significantly different. So here is my ANOVA, and this should look very familiar. This is my ANOVA summary table, just like we talked about in class. I have my between groups, my within groups, and my total. So I have my sum of my squares for between, within, and total. Then I have my degrees of freedom for between, within, and total. And remember, if I take my sum of my squares, divide it by my degrees of freedom, I get my mean squares for between. If I take my within groups and my within groups sum of squares, divide it by my degrees of freedom within, I get my mean squares within. And then if I divide mean squares between by mean squares within, I get my F ratio. Now what I really want to pay attention to here is that it gives me my significance value. So I don't have to estimate it by using my critical region. I can say, okay, P equals 0, 0, 0. So we don't know, again, PSPP only reports to us 3 digits. So we don't know if this is truly 0 or if the next one would be 1. So we're going to say this is less than 0.001. Now if I want to save this PSPP output to turn in, I would go to File, Export, I give it a name, right? Maybe I'll call it Lab for ANOVA. And I'll say, save it to the desktop, and let's make this a PDF file. And then I click Save, and I'm going to see that it's saved as a PDF here on my desktop for me to submit with my lab assignment, or I can upload it. All right, so that's our ANOVA part of it. So let's go on, and let's now do our correlation demonstration. So we're going to look for the Lab 4B data. Now in PSPP, we have already got some data open. So I'm going to use this. I'm going to open, and now I'm going to open Lab 4B. And you'll see Lab 4B is smaller. So to avoid confusion, I'm going to close this employee data, close without saving. And let me see if I still have my output open. I do. So I'm going to close that. So now I just have my Lab 4B data, and I'm going to say, okay, let's read all about correlations, remind myself I'm dealing with Pearson R. I report this in APA style as R, degrees of freedom. Now what you have to really remember about degrees of freedom when you're talking about correlation is degrees of freedom is your total sample size minus 2. You lose 1 degree of freedom for each variable because your correlation is always the relationship, the correlation between 2 variables. And then you have your value of your Pearson correlation, which ranges from -1 to +1. The closer to 0 it is, the smaller the correlation, the higher it is, the stronger. And then you have your p-value. So here's an example. I know R, 24, so this is my degrees of freedom, so I know that the sample size was 26 here. 0.85, this is a positive correlation, and it's a significant correlation in my data because P is less than 0.001. So I have my little table again to help me remember, right? If a p-value is less than my alpha level, if my alpha level is 0.05, it's a significant result. If it's greater than that, it's a not significant result. So let's look at our background for our demonstration for our correlation. Now, a lot of times this comes up in political debates about gun ownership and murder rates, right? This is very timely. So we have a little fake data set that we are saying is from the FBI and the ATF, right? And we are looking at the number of registered automatic weapons in thousands and the murder rates per 100,000 for selected areas, right? So we want to know, is there a correlation to determine whether the number of registered automatic firearms, not those unregistered, registered automatic firearms, is related to murder rate in those different locations. So our research question is there a relationship between the number of automatic weapons and the murder rate? So we're going to go into PSPP in our data. We are going to go to Analyze, and actually, correlation has its very own menu, bivariate correlation. We click on this. So we only have 2 variables, so I can highlight both and click them over, and we're 2-tailed, and we'll click the box for flag significant correlations. So all I had to do was move my variables from this box to this box, and then click OK. And here is my output. So this is what's called a correlational matrix. So it's always going to repeat itself. It's going to show you the same results twice. Because remember, it's a computer, it's a software program, it doesn't know what it's doing. So it automatically calculates the correlation between automatic weapons and automatic weapons. No big surprise there that the correlation would be a perfect 1 because they're exactly the same variable. So we need to ignore this, right? And then we have the correlation between automatic weapons and murder rate. So this is what we're interested in. the 0.88 correlation. So the first line is the actual Pearson R. So this is what you report for the correlation itself. This is a pretty strong correlation, 0.8. Now remember, the closer to 1 it is, the stronger the relationship is. Now the second line is very important as well. This is our p-value, this is our significance level. So we'd say p equals 0.003, so that is less than 0.05, so we'd say there is a significant correlation in our data. And then we have our sample size, our n. So if we were going to report this as degrees of freedom, we would subtract 2 from this. So let's go back into our problem here. And let's look at this, right? Okay, so our conclusion here is that the number of registered automatic weapons is positively correlated with the murder rate. So we say our conclusion in words, comma, R, so we know that it's a correlation, Pearson R, degrees of freedom, so the degrees of freedom is 6 because we had n, sample size was 8, so we subtract 2, right? We lose 1 degree of freedom per variable, equals, and you don't usually report that plus sign, but I have it here as an example just so, because we're just learning this, we want to be able to tell immediately if it's a positive or a negative correlation, right? 0.88 p less than 0.001. So we are almost out of the woods here with our correlation. So you might say, oh, we're done. Now, if you were curious about how much variability is shared between these two variables. So maybe you're wondering exactly what the coefficient of determination is. We talked about that in class. So what is the proportion of shared variance, or how much variance is accounted for in one variable by the other? So if you think about I think of this as like a pie chart, right? So you have a whole circle is 100% of the variance. So we want to know exactly how much of the variance in one variable is accounted for by variance in the other variable. So what we do is we take Pearson's R, 0.88, and we square it. And that resulting value, here it's 0.7744, so I would just round this to 77, right? And we multiply that by 100, 77% of the variance in one variable is accounted by the other variable. So that means that this murder rate is really strongly related to the number of registered automatic weapons. So we can't say, we talked about this in class, right? You can't say that one causes the other. We can't say that owning a registered weapon causes murders, or murders cause people to buy registered weapons, right? But we can say that there is a strong relationship, and that 77% of the variance in one variable is shared by the other, right? So we can say it as shared variance or variance accounted for. However you think about it, this is R squared, the coefficient of determination. All right? So you're going to be asked about that in your homework. So it wasn't really something we were thinking about for the lab assignment, but we're going to have a question about that in the assignment. So again, I hope you enjoyed this demonstration. You're going to do your Lab 4 assignment. You're going to do your book work. You're going to do your own ANOVA comparing 3 different locations. You're going to answer your questions about the null hypotheses. You're going to report the means and standard deviations. You're going to give your opinion on what you think about that ANOVA based on the descriptives. And then you're going to report the actual findings, your conclusions from the ANOVA test, right? And then you're going to do a correlation using the college data set. And you are going to correlate average SAT score and grad rate, and you're going to be answered the questions about if it's a significant relationship, what the direction is. So the direction, is it positive, is it negative, what is the strength, how close to 1 is it, how close to 0 is it, and you're going to report R squared. So you're going to have that Pearson R, you're going to square that, and then the result of R squared is going to be the percentage of variance explained by the other variable. So these are actually questions that are asking the same thing, but I'm checking your understanding. Do you understand what R squared actually means? And then you're reporting the results of this in a sentence with your APA style. You can look at the PSPP guide for examples. You are going to be, again, turning in your bookwork, your problems. You are going to turn in your 2 different outputs. So you have 1 output for your ANOVA, part A, 1 part for your correlation, part B, and then you're going to answer the questions about that output in part A and part B, staple it all together, and turn it in class. Well, I hope you enjoyed this PSPP video and that it was helpful. Please feel free to email me with any questions or concerns or talk to me in class. Thank you. Bye.